our unit for exponents, exponential functions, and logarithmic functions. Do not panic. We'll go through it slowly. We're going to start with exponential, which you should be comfortable with. And we're going to get into most of it we do with functions. The hardest part of it is probably when you see your windows in your calculator because it uses larger numbers. So we're going to start with the basic exponential formulas, and then we're going to work our way up. Today is good because it's a short day. It is a pretty short lesson, and this should probably stay easy too. We're starting very, very basic. Danielle, the two sheets are right there, and there's a vocab in that folder on left one on the top. And if you have your extra cut, I'll take that. It is. I apologize, but we can't do anything about it. So let's just get through today. Boy, it's tough loud as it is, and I'm not a very loud speaker. Okay, so now, basically we start here. When we throw functions in here, I'm going to change this up a little bit, but right now, basic exponential functions. Exponential things grow, like if I took this paper, and if I make no fold, I have one sheet. If I make one fold, I have two. If I make two folds, I have 11. Have 4. If I make 3 folds, I keep a half. 8 belongs to the 0, to the 1. Well, to the 0, to the 1. To the 2, the 2, is the exponential growth. It's not a steady growth, it's an exponential growth. More folds on me. Except for my curve will go up. Now, when we do this, we're going to start when it's positive, when this is positive first, when this is real numbers, we're no imaginary anymore. And we're just going to do a basic graph of this. So if you put this in your calculator and give me a basic graph, what does a negative exponent do? Anybody remembers what the negative exponent does? You put it 1 over the positive. If it helps, go like this. Factor out the negative 1 out of any exponent. This negative 1 flips this over, it takes the reciprocal. And then your exponent stays positive. And yet that's going to be a small number. We don't get any negative numbers in this. They're going to, when you use a negative exponent. It's going to stay a positive number. So if you put this in your calculator, these are the numbers you get. Okay? Now, basic curves. Let's talk basic curves. Today is very, very basic, so it's nothing to panic about. Again, and this is where I thought you might remember asymptotes from. This axis, this x-axis, this is where y is equal to 0. This is an asymptote. It's a natural asymptote. Because if I use this equation, is there any value of x that I can put in that would give me a 0 for y? Nothing. If I put a 0 in for x, anything to the 0 power is 1. If I put any negative numbers in, I get fractions. So this x-axis, which is where y is equal to 0, is a natural asymptote. This will keep getting closer and closer and closer to that axis, but never touches. We don't have any negatives as outputs either. This common point right here is where they will all share this intersection for basic equations. That's a common point right here. Is this function increasing or decreasing? Increasing. What's the domain of this function? All real numbers. They're in only real numbers No imaginary. What's my range? Zero. Can I use zero? No. So soft bracket to infinity. Okay? And therefore this is going to be an increasing from negative infinity to positive infinity. Okay? Very, very basic. Now, if I use the next table, I don't want to move mine, but if I do y 2 to the 5th, all that says is this. I'm going to do this in blue. All that says is this. These numbers will get smaller and smaller here. They'll pass through here, but they will go up a little sharper. Because if you do 2 to the negative 4th, it's a lot smaller, right? If you do 2 to the 5th, it's a lot larger. So it keeps the same increasing. It passes through the same point, 0, 1. Because again, sorry, what am I writing here? I told you this throws me off when something happens here. 5 to the x. If I put a 0 in for x, I still get a 1. So that's going to be a common point through all of these exponential functions. All I did was change the base. It was just a little sharper. So we're good with that. Pretty much you did this 10th grade, 10th grade, probably not 10th grade, probably not beyond 3. But algebra 2, you did this as well. Alright, so now, let's just establish a few of the rules here. As I said, this is just basic review today. We're going to throw the negative exponent in a second. Okay. Underline continuous function. Alright, so let's start basic. Core graphs. We call these cores or parents. Sometimes you call it a parent graph. What did you guys call it? Parent. Parent graphs. Okay, again, any increasing one is going to go like this. It's going to have the same attributes for all of our basic increasing ones. We're not doing any transformations, just basic. Your domain, again, is all real numbers. You can use any x value you like. Your range, you can never get a 0 out of this, but all infinity. Your y-intercept is going to be a 0, 1. This guy, increasing or decreasing, did we say? Increasing. As x approaches infinity, your y value is constantly increasing over the whole domain. The asymptote is what? Y equals 0. Good. It is your x-axis, but call it y equals 0. And we call this a continuous function. You put your pen down and you never pick it up. It just keeps on going. It goes continuously. Okay? What does this negative exponent do? 2 to the negative x. Yeah, but what's it going to do to our graph? Like, okay, think about negative x. When I take the x and I go from positive to negative, it flips it, it reflects it. Where is my reflection? Over the y-axis. The rule is when you go and you negate the x, you get a reflection over the y-axis. So this technically, yeah, it's going to change it a little bit, but it's going to give me a reflection this way. I'm still going to pass through the same point, because if I put a 0 up there, 2 to the negative 0, which is 2 to the 0, I still get a 0, a 1 out of this. It just reflects this. My domain will stay the same. My range will stay the same. My y-intercept stays the same. But now, I'm decreasing. My asymptote stayed the same. And I'm still a continuous function. All it did was give you a reflection. Most of our work is going to be off of your transformation. I don't have the sheet with me. Just think of your transformation rules, the same we've been using. When the negative is next to the x, just move your finger from positive to negative x. You're going to see your reflection. When it's out in front here, it's going to be a reflection over the y. It's not near the x, it's near the y. It's going to have the same rules. Most of our work off of our exponents are going to be through transformations. So you're going to be surprised again how much you can graph without the use of your calculator. Are we okay with basics? Everybody's pretty good with this. Today, very, very basic. Very basic. Okay. We're going to work off of transformation. So we're going to start with your parent graph. What would your parent graph be for this guy? 2 to the x. So originally my parent graph looked like this. A domain, all real numbers, range from 0 to infinity, passes through 0, 1, blah, 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 blah. What does this do? Yeah. So let me think back to something that I was comfortable with. Think back to your squaring function. This does what? This one does what? Boost it up 5 units. Vertical shift up, right? What did this one do in the middle? Horizontal. Which way did it go? To the left. Good. It went the opposite way. So this is giving me a horizontal shift left 5 units. So technically, I'm taking this point and I'm moving it left 5 units. Does my domain change? No. Did my range change? Nope. Did my asymptote change? Nope. What changed? The y-intercept. My y-intercept changed. So the only thing that we have to worry about is your y-intercept. And how do we find the y-intercept? We plug in what? A 0 for x. So we're going to take this equation, and we're going to plug a 0 for x. So your y-intercept, whatever this happens to be, 2 to the 5th is 32. 32? 32. 0, 32. That's the only thing that's going to change on this one. Okay. So we work all of our graphs off of transformations. Good so far? Just remember back to the parabola, because I think the parabola is the easy to remember it back to, because it's probably our most common one that we use. So think what happened in those first, and that'll help you out. Okay? What's your core graph? Your parent graph, sorry. 2 to the x. So we're going to start with y equals 2 to the x. What does this plus 5 do? Good. This is a vertical shift. Make sure you use the right words. Up 5 units. So easiest way is to take this point, just so that you get a good feeling for this right now, and move this up 5 points. So if I add a 5 to here, I'm somewhere at the 0, 6. So this is going to go through, through here and up. If this was your y equals 0, you're going to move this up to 5. I told you I don't function well when other things are going on here. So here's my asymptote. Move everything up 5. Anything that affects the vertical, you need to change. Did my domain change? My domain doesn't change. What is my range now? God bless you. 5. It was at 0. So if I was the y equals 0 for my asymptote here, and my range was 0 to infinity, both of these, I'm just going to add 5. Because you're just following your rule. So your new asymptote is y equals 5. And that's how you can figure out your range as well. Sound good? Still familiar? But I don't know if last year if you put them in your calculators or you actually went through your transformation rules, but you guys seem to be pretty sharp on transformations for the other functions that we did. So I'm kind of thinking you did transformations with these too.
We're just naturally good.
Naturally good. You're naturally smart. Okay. All right. And one more. This starts again with my parent graph. Here's my parent graph. Now, this negative is not next to the x, it's next to the y. So I had a rule that said negate the y. If my y goes from positive to negative, where's my reflection? The x-axis. And use the word reflection. So I'm just going to take this, maybe the easiest point to start with is this one. This now becomes 0, -1. And I'm going to reflect it. Did my domain change? Yes or no? No. No. All real numbers. Did my range change? Yes. Because I reflected it, come from the bottom. You're coming from negative infinity. Where you're going to stop at? 0. Can I use 0? No. Did my asymptote change? Nope, I went over that asymptote. I reflected over that asymptote. So my asymptote stayed the same. And my y-intercept just went 0, -1. Good? This is very, very basic today. I don't want to scare you before we even get into the hard stuff. Oh, it's not that much.